So the next kind of delay is called as propagation delay. We are discussing about propagation delay. Propagation delay. So what is a propagation delay? Assume this is the host H1. This is the host H1 and this is the host H2. Host H1 and this is host H2. Host H2. And they have a transmission media between them. This is the transmission media. Transmission media. Now, if we have some data packets here, this is the data packet. The time taken to transmit this data packet to the transmission media is called as transmission time. Time taken to transmit this data packet to the transmission media is called as transmission time. Okay. Now, when we discuss about this propagation time, then propagation time means the time taken for one bit to travel from host to the destination is called as propagation time. It is generally represented by TP. It is generally represented by TP, or you can say propagation time. What is propagation time? Time taken for one bit to travel from source to destination is called as propagation time. Is called as propagation time. You can check the spellings. It is called as propagation time. Now, on what factors the propagation time is dependent on? You can clearly see that propagation time is directly proportional to the distance between the host, or you can say the source, and destination. It is directly proportional to the distance between the source and destination, and it is inversely proportional to the velocity, or you can say speed of the signal, or to the velocity of signal, to the velocity of the signal, to the velocity of the signal. So what is the propagation time? Propagation time can be written as it is distance between the source to destination upon velocity of the signal, upon velocity of the signal, or distance upon velocity, or distance upon velocity. For example, if I say that assume the distance is 42 kilometers between the source and destination, and velocity of the signal is 2.1 into 10 raised to power 8 meters per second. Velocity of the signal is 2.1 into 10 raised to power 8 meters per second. Then what is the propagation time? Then propagation time can be written as distance upon velocity, which is 42 into 10 raised to power 3 meters. 42 into 10 raised to power 3 meters upon 2 raised to power 1 into 10 raised to power 8 meters per second. Meters per second, or you can say second is multiplied here. Meters per second. So you can clearly see, just to remove this dot at this point from 2.1, I can make it as 10 raised to power 4. Now you can see 21 into 2 is 42, and you can divide this by this, so it will be written as 2 upon 10 raised to power 4 seconds. 2 upon 10 raised to power 4 seconds, which is equal to how much? You can write it as 2 into 10 raised to power minus 4 seconds. 2 into 10 raised to power minus 4 seconds. Now you know the units. What are the units for seconds? You can say 1 second is 10 raised to power 3 millisecond. 1 second is 10 raised to power 3 millisecond. 1 second is 10 raised to power 6 microsecond. 1 second is 10 raised to power 6 microsecond, and 1 second is 10 raised to power 9 nanosecond. 1 second is 10 raised to power 9 nanosecond. So you can say 1 millisecond. Here from this you can say 1 millisecond is equal to 1 upon 10 raised to power 3 seconds, or you can say 10 raised to power minus 3 seconds, or you can say 10 raised to power minus 3 seconds. 10 raised to power minus 3 seconds. Okay, 10 raised to power minus 3 seconds, right? So you can call it as 0.2 milliseconds, 0.2 millisecond, because it is 2 upon 10 into 10 raised to power minus 3, 2 upon 10 into 10 raised to power minus 3, which is equal to 0.2 milliseconds, or you can convert it to microseconds. You can also convert this to microseconds. So how many microseconds will be there? So it is 2 into 10 raised to power minus 4. So you can call it as 200 into 10 raised to power minus 6 seconds, which is equal to 200 microseconds, which is equal to 200 microseconds. Now you know what is this propagation delay. Generally, when we discuss about the computer networks, in case of optical fiber cables, if we use the optical fiber, generally the signal travels with a 70% speed of light. 70% speed of light. That means if the speed of light or velocity of the light is 3 into 10 raised to power 8 meter per second. Now in case of optical fiber, the signal travels somewhere around 2.1 into 10 raised to power 8 meters per second. That is why I have taken this velocity as 2.1 into 10 raised to power 8 meters per second. Okay, now you know what is propagation time, and let us discuss about the next kind of the delay, that is called as the processing delay and the buffering delay. Okay, processing delay and buffering delay, or you can say queuing delay. Okay, let me rub it up.